Thank you very much, Tim. Yeah, so for this afternoon's presentation, despite the 7 or 8 members of the panel, it's myself, Dr. Petrus Gunarso, and Dr. Kali, and Dr. Bambang, who are directly responsible for this presentation. So there is a claim that more than 50% of deforestation in Indonesia and Malaysia is due to development of the oil palm plantation. Just to clarify that one, but that's not the most important objective. There are many other important things, which is the estimation of greenhouse gases as caused by the land use changes. And to document the sources of emission and what are the sources of uncertainties. And also to estimate what will be the future emission and to model the emission reduction scenarios. But our progress now is on the 3 points. So this is about delineating the land cover maps of different years and then multiply them with the emission factors. And we will have the historical emission. And the future work will be to project what will be the emission looks like and recommend what will be the emission reduction scenarios. So there are many sources of emission. The first one is the loss in the biomass because of the change in the initial land use. It could be the land use with a very high biomass, or it could be land use with a very low biomass to oil palm plantation. And the second source is the oxidation of organic matter from the soil, be it mineral soil or peat soil. The third one is the peat soil burning. So the burning of the above ground could go into the peat, but it is handled separately by Dr. Bambang Winarso, and we cannot incorporate it into the national level analysis. So this is about the emission factors, and there are uncertainties because of the range in the estimate of the above ground carbon stock. So the groups on the left-hand side are the forest, and the middle one are the plantation, rubber, oil palm, and so forth, and the one on the right are the annual crops, grassland, and so forth. So if you change your land from the forest to the plantation, this is certain that you are going to lose some of the biomass and vice versa. And the second one is the emission from peat oxidation, and there is also lots of uncertainty. And the fact that we are using, what we are using now is the linear relationship, but the truth in the field, it may not be a linear relationship. So we adopt the model, the linear model from Hoyer, but we discount for the root respiration. The root respiration produces CO2, but at the same time, CO2 from the air is absorbed through photosynthesis and accumulated in the plant tissue. And on the emission on the mineral soil, there are literature which shows an increase in carbon stock when you change degraded forest into oil palm plantation. If you manage organic matter very well, very intensively. And in most cases, however, if you change the forest into plantation and into other kinds of agriculture, you're going to lose the organic matter and carbon. So this is the example of the map of the land cover for oil palm plantation, but the whole story is not the delineation for oil palm, but all sorts of 22 land use classes. So we have 1990, 2000, 2005, and 2010. So what you can see here is a rapid development of oil palm plantation. This is the example of Sumatra. And a big portion of peatland has been used. It's about 20 to 22% of peatland comprise all of the Sumatran oil palm plantation. This is the example of land use change matrix. So from this land use change matrix, you can see all sort of trajectories from, for instance, forest to rubber plantation, from grassland to plantation, and so forth. And this is used as what we call the land use or land use trajectory data. And from that, we summarize it into this oil palm development graphs. So what we see now here is that in Indonesia, in these three major islands, there are around 7.7 million hectares of oil palm plantation. The majority of it is in Sumatra, and Kalimantan is rapidly developing, and Papua is still starting to develop their oil palm plantation. And as shown before, that the peat soil, especially in Sumatra, is one of the major components of the oil palm plantation development. And when we analyze, when we separate what's the initial land use that changed into oil palm plantation, so what you can see here is that 28% of the current oil palm plantation was from the conversion of forest, but the conversion of undisturbed forest is relatively very small. So the majority of it is the disturbed, the log over forest. And 17% of this oil palm plantation in Indonesia, in the three major islands, have been there in 1990. So the sum of all of these graphs is the current figure of oil palm plantation. So the rest, about 55%, comes from different land use, from other agricultural, from other plantation land uses. And when we evaluate deforestation, both the undisturbed and disturbed forest deforestation, from 2000 to 2005, only about 7% of the deforestation ends up in oil palm plantation. But in the last 5 years, the area increased dramatically to 27%. But around 30% of the deforestation ends up in shrub or wasteland. So the message here is, if you can use the shrubland rather than using the forest, you save significant amount of carbon. This is the figure in Malaysia. So in Malaysia, the use of peatland is not as high as it is in Indonesia. It's around 13%, but the majority of peatland use is in Sarawak because of the dominance of peatland in the state. In PNG, the current figure is around 140,000. So this is what we found out from the Google Earth, because they have very clear, very high resolution Google Earth for PNG. And for the newly developed areas, so they depend mostly on forests, but with time the dependence on forests decreasing. So the emission calculation is the multiplication of the activity data with the change in carbon stock, or the activity data is the IPCC term for area that we are taking into account. And the C stock could be the emission rate, so whatever data that you have. So it's basically land use change metric times emission factor. And this is the example of the result of the matrix calculation. So the minus value is the sequestration. This is just for the above ground example. And the